Thanks a lot, David, for this nice introduction. Thanks a lot for having invited me to give this talk. Yeah, what is a sustainable use of ICT as a question, as a title of my presentation. Now, it should move or not. No. Now, very shortly, I want to touch 4 issues in my presentation. What means sustainable? How can we measure sustainability? What are the impacts of ICT and the substitution effects that are related to the use of ICT? Sustainable, here the classical definition, sustainable development, how it was defined in 87 in the Brundtland report. In other words, we haven't inherited the earth from our parents, but we borrowed it from our children. So this view towards future generation, that's one of the central points of the whole sustainability discussion. And this is putting so strong requests in the end on resource conservation and the environmental protection as an issue. And now, how can we measure sustainability? I would say we can measure it, at least the environmental part, with the life cycle assessment with the Lca method. Lca is a comprehensive approach. It's quantifying ecological and human health impacts of a product or of a service over its entire life cycle. It's based on scientific methods, modeling methods, and in the end, it can help a decision maker then to understand the scale of the environmental, but also of human health impacts when taking decisions. Practically, an LCA, this is, let's say, 2 modeling steps. In a first step, you establish your life cycle model, and then you collect the data. You collect all the interactions of your system with the environment. So a kind of input and output analysis. And you can then sum this up in order to get the cumulative resource consumption and emissions that your system in relation to the functionality is producing and consuming. And in a second step, we are assessing these exchanges, so this resource consumption, these emissions in relation to what is this impact standing for, like the global warming potential that you mentioned already before. Now, if we look for ICT devices, what are their impacts? We did a small study for a book that has been published some years ago, where we were really looking on different devices, taking into account production, use, and end of life. So really looking on the complete life cycle of these. The rationale behind was really to look what is in the end more important, the longer lifetime that you have for the bigger devices, or the smallness, the more efficient architecture that you have when we look on small devices like a tablet. So the question here to see is, what is an adequate, fair way to compare these devices? If, for example, I take a desktop computer, a laptop, and a tablet. Of course, I can do simply the comparison on an impact per hour of use of these 3 devices. What you see here is the global warming potential on the left-hand side, on the right-hand side, with recipe, one of the methods that we have that takes into account all environmental aspects, not only the global warming. And the pictures are rather clear. It shows a tablet is about 10 times better in that sense from an environmental point of view than using during 1 hour a desktop computer. However, on a time scale, if we look on how was ICT in your family 10, 15 years ago, almost 20 years ago now, we had 1 computer in the family, and nowadays we have a lot of mobile devices in the children rooms and so on. You have tablets, smartphones, laptops, and so on. And so looking on the impacts per hour of use is probably not the adequate way to look on it. Rather, we should look on the daily impacts of the use of the complete park of devices that we have in that sense. And then we see, oops, despite that we got more mobile devices, overall, probably we are creating a higher impact. And then there is coming an additional element. We are not only using our device, but we are using what is called the internet in order to store data, in order to search information, in order that I can make my presentation to you today, we need this whole infrastructure. And if we try to quantify this infrastructure, and here we added the impact for the download of 100 megabytes to these 3 devices, then we see that actually the impacts that we create outside of our home, so the orange bar for the internet, is much higher than the impacts that our own device is creating. And if I combine all these and we take into account that the download speed increased, that we are more mobile, more looking onto other devices today than we did in the past, overall, we come then to the conclusion that there is a clear increase of the daily environmental impacts due to the use of ICT devices in a family, this model family that we used here, but also in other configurations. Of course, our day has only 24 hours today, like it had yesterday. So a higher increase of ICT means we are substituting other activities by ICT. So the interesting element then is to look also on these substitution effects that we are creating. Classically, we can say, and that is what brought me to Empa actually, a study where we were looking on ICT replacing paper. Like you have seen on the picture before here, reading the news in the morning on a tablet instead of reading it on a newspaper. We did a small case study in a different area, advertisements for a supermarket. I mean, supermarkets, they do advertisement in the television. So I have the impacts of a television spot. Most of them, they have a website. So I can go and surf on the website. I can do this with my mobile phone. I can do this with a desktop computer. And obviously, as we have seen before, the impacts of the device is rather different. Or they have the classical leaflets. And such a leaflet nowadays, it can be on paper form, or it can be a PDF on the internet. So what you see here is the paper form and downloading the PDF to a tablet or to a desktop computer. And so in the end, if we look on these elements here, we can see that the most sustainable way in this context here is to read offline the PDF of the leaflet on your tablet. So ICT replacing paper has a positive effect from an environmental point of view. ICT is also replacing traveling. That's something we managed in the past 2 years with the COVID crisis to do an even bigger proportion. This here is from a study we did more than 10 years ago together with Microsoft here in Switzerland, where we were looking on 2 cases. One, an in-person meeting where one person from Switzerland is traveling to the UK, to London. We have then people using a laptop in the meeting, and this person can travel by train, by car, by airplane from Switzerland to the UK. Or we make a virtual meeting using all the infrastructure that Microsoft had available at that moment in time, using laptops, using in a meeting room a beamer, and having behind the whole data transfer servers and so on, according to the information we got then from Microsoft. If I look just on the global warming now for this situation, assuming that the meeting takes 1 hour, you see here the impacts, the virtual meeting on the right-hand side, so here, and here the 3 options depending on how I'm traveling. So first thing we can see is that the way how I travel can influence quite considerably the overall impacts of my meeting, because I can reduce by switching from the car to the train by more than 260 kilograms the global warming potential of my trip. I can even more reduce it, even by almost 100 kilograms more by switching from train to a virtual meeting. So again, ICT shows a much lower impact than the traditional way of traveling to a meeting. David, you mentioned my last study was about the 5G networks, and this study, in a way, was really trying to put together the opportunities that new technologies bring with them, with the impacts that they are causing, and the savings that they are creating on the other hand side. And so we were in this study explicitly looking in two different ways on 5G. On one hand side, we were really looking on the direct effect. We did a classical LCA where we were just looking on the components from 5G, so the mobile network, so the access part, the core network part, the transport network part. We were not looking on the data centers. We were not looking on the mobile phones from the users, but just looking on the network itself. And Swisscom was one of our collaboration partners. So really, we had access to direct data from the network that they are currently establishing. In the second part of the study, we were looking on different use cases and the potential that they bring with them in order to allow to reduce the overall greenhouse gas emissions in Switzerland up to 2030. In a literature study, we were identifying all the areas where 5G could bring new opportunities. You see here them listed like agriculture, transport, but also energy supply, entertainment, of course, the public area, flexible working, but also issues like building management or the health sector. And based on this literature, we then choose the 4 sectors that showed the highest potentials, according to literature, means agriculture, the transport sector, energy supply, and flexible working. And for each of them, we were then trying to calculate on one hand side, what is the reduction potential that we see for flexible working, for example, by reducing the commuting amount that the worker is doing over a week, reducing the office space in the company then means reducing heating and so on, but taking into account also possible rebound effects. If I don't have to commute to my working place, I need less time in the end to get my work done. So I have more spare time. And what do I do in this spare time? Do I just take a walk next to my house, or do I jump into my car driving 30 kilometers in order to do my walk around the lake that is outside the city? When we quantify these elements on the side of the direct effects, we clearly see that if we look between 2020, 2030, the annual impacts, the annual greenhouse gas emissions from the direct, so from the infrastructure, they will increase. Overall, the network infrastructure in Switzerland 2030 will have a higher impact per year than in 2020. However, taking into account that the data volume is about 10 times higher in 2030 than in 2020, if we break this down per gigabyte of transferred data, we see that 5G results in a much higher efficiency for the data transfer with about 85% lower greenhouse gas emissions compared to the current installed technology here in Switzerland. Now, looking on the indirect effects, the savings, of course, there are high uncertainties due to this view in the crystal ball, in a way, how these opportunities will evolve. We were distinguishing between a pessimistic and expected and an optimistic scenario. You see here the values. So in total, we expect about 2.1 megatons of CO2 equivalent savings up to 2030 in the optimistic situation, 0.1 in the pessimistic, with the highest values for the flexible working and smart grid. Autonomous driving has a rather small saving potential up to 2030, simply because this technology will not be evolving completely until 2030. So the overall potential there is coming after 2030. But in order to do these savings, we need additional infrastructure. We are not only requiring the 5G networks, but you need additional infrastructure, flexible working. You need a laptop computer. It's difficult to take your desktop computer under your arm and go and working outside. Then you depend very much on how long is your power cable. And so what you see here is, again, pessimistic, expected, optimistic scenarios for these values. Yes, I'm close to the end.
Yep.
If I combine all these together, direct effects, additional efforts, and put this in against the savings you see here for the 3 scenarios, that what we can see is clearly that the 5G network capabilities, they can make a significant contribution in order to reduce greenhouse gas emissions. Conclusion: sustainability of ICT has always a direct as well as an indirect component. And in the end, it implies it results in changes in the behavior of our society. Obviously, the smaller and the more mobile a device, the more relevant is its production, and the longer in use it should be in order to be more sustainable. Changes directly in our society, they can result in a considerable overall reduction of the impacts, but we have to take care that eventual rebound effects are not eating up these reduction potentials. So overall, each of us that is defining in the end how sustainable ICT use will be in the future. Thank you.